Okay, I already have the answers drawn in here. It's because the last time I tried to record this, it didn't work, but hopefully that won't make it less obvious how the answers are reached. If you have a vertical reflection line and you're reflecting it, the image is the same distance from the reflection line as the object. So you can see that this point is 2 squares away from the reflection line, which means it's going to be 2 squares away on the other side when you reflect it, so it ends up here. This point here is 1 square away, so when you reflect it, it's going to be 1 square away over here. And this corner piece, the right angle is 2 squares away from the line, so when you reflect it, it'll be 2 squares away again. That's how you get the 3 vertices, and hence that triangle. With a diagonal line going 45 degrees here, the distance from the line is measured along diagonals going in the opposite diagonal, this way. So you look at this point, and going along the opposite diagonal, it's half a square away, which means the reflected point will be half a square away on the other side. This point is 2 squares away along the diagonal, so the reflected point will be 2 squares away along the diagonal, and over here. And this point is 1.5 squares from the line, so if you go 1.5 squares in the 1.5 squares again away from the line, you get here. And so the reflected image that we get is this one. If you're doing this properly, you do it in pencil and with a ruler, obviously, and you wouldn't have these construction lines, but that's how you work out where it ends up. With the rotation, tracing paper helps. It's not essential, but if you're finding this difficult, it certainly helps. I don't have tracing paper exactly here, so hopefully you'll still be able to see what I'm doing. I'm going to trace the shape, I'm going to put the pen on the point, and I'm going to turn through 90 degrees. If you have trouble keeping track of 90 degrees, let's use a straight edge again. If you have trouble keeping track of 90 degrees, one of the things you can do is to mark up as a little additional arrow on your shape. Now when you turn this through, that up arrow, you can see it, is now going to point to the right, and that means the up arrow is turned through 90 degrees, it's gone from north to east, and so our shape ends up here. Now you have to look at the graph and see where that shape is, and remember at least one crucial point. So I'm going to remember that this point is 1 square from the right hand edge, and now that I know that, I can go back in and draw the shape. There we go. With the 180 degree rotation, I'm going to use the same template because it's the same shape, but the rotation point is here now, so that's the point that I'm going to fix the pen on and turn it to 180 degrees. Again, I can use the up arrow trick to help, so I'm going to put it on this side so you can see it better. There's the up arrow, not a brilliant up arrow, but when that arrow points down, then we know that we've put it in the right place. So turn the paper, that's pointing left, there's the old up arrow, let's get rid of that so it doesn't get confusing. And now it's pointing down, and my shape has ended up here. So again, pick a point that you can remember, that point there, and now you can draw the shape in. And that's the shape rotated through 180 degrees. Final question is about order. Order, remember, is the number of times a shape matches up when you rotate it through 360 degrees. I'm going to get another bit of tracing paper here. So if I trace this shape very roughly, and I spin it around on top of the original shape, how many times does it look like the original? Clearly it doesn't look like the original yet. Okay, now it does, that's 1. I'm going to carry on going until I turn it around through a full turn. Still doesn't look like the original. Oh, now it does again twice. So in a full turn, it's matched up with itself twice, so that has order 2. With this shape, okay, I'll try and draw it quickly. Piece of paper. Looks like this. When I spin this round a full turn, and again I'll use the arrow to remind myself when I've done a full turn, how many times does it look like the original? Well, there's one matchup, and you probably can't see this very clearly through the paper, I can. Second matchup, that's 2. Third matchup at 3, that the up arrow tells us we've done a full turn now, so that's matched up 3 times. and the order is 3. You can probably see that just by looking, though. It's this windmill with 3 spikes. Clearly, it's going to match up with itself 3 times as it turns through a full turn. Hopefully, that makes sense. And that's what the order of rotational symmetry is asking for. How many times, when you rotate it through a full turn, does it match up with itself, including